Demand planning is the process of predicting future customer demand so that the business can make better decisions around inventory, purchasing, production, promotions, and supply chain operations. At its core, demand planning answers a simple question. How much of each product are we likely to sell in the future? To answer this, TrueGradient analyzes both internal and external business drivers such as historical sales, promotions, pricing, seasonality, holidays, market events, weather, product lifecycle changes, and other signals that influence demand. Using these inputs, the platform generates forward-looking forecasts that help planners balance product availability, inventory investment, and business growth. In the next section, we'll understand the different types of demand signals and forecast views available within the platform. The forecast value add chart is the primary visualization used to compare historical demand, forecast projections, and planning decisions over time. Let's begin with actuals. Actuals represent what has already happened in the business and serve as the foundation for evaluating forecast performance. Sales represents the observed demand captured from business transactions. In some situations, historical demand may be incomplete due to stockouts or missing observations. Imputed actuals help estimate what demand would likely have been under normal business conditions. Forecasts represent expected future demand generated by the planning system. Multiple forecast versions can be viewed and compared depending on the planning workflow. The locked ML forecast is the machine learning forecast frozen at a specific planning cycle. Consensus forecast represents the agreed forecast after planner review and business collaboration. Depending on configuration, planners can compare machine learning forecasts, reinforcement learning forecasts, time-based forecasts, and other forecast variants generated by the platform. Comparing forecast versions side by side helps planners understand differences in assumptions, accuracy, and business impact before committing to a plan. Forecast uncertainty is equally important as the forecast itself. Prediction ranges provide visibility into potential upside and downside demand outcomes. This helps planners assess risk and prepare for different business scenarios. Rather than relying on a single number, planners can understand the range within which future demand is expected to occur. Forecasts are not static. As new information becomes available, plans evolve over time. Snapshots allow planners to compare current forecasts against previous planning cycles and understand how assumptions and expectations have changed. Finally, factor contribution explains why the forecast is moving in a particular direction. Here we can see the relative influence of different drivers such as holidays, pricing, promotions, seasonality, calendar effects, and other business variables. This provides transparency into the forecast and helps planners understand not just what is expected to happen, but also why. Together, actuals, forecasts, forecast value add, prediction intervals, snapshots, and factor contributions provide a complete view of demand performance, forecast evolution, and future expectations within TrueGradient. At the top of the dashboard, planners get a quick summary of key planning indicators. Depending on the selected view, these metrics can be analyzed in both units and revenue terms. Key KPIs include the total forecast, year-over-year growth, and recent sales performance across 30-day and 90-day periods. This allows planners to quickly understand overall demand movement and business performance before reviewing item-level details. The Demand Planner table provides a detailed operational view of planning data at the SKU and location level. Each row represents an item-level planning record, while columns organize forecast, sales, inventory, and planning intelligence into a single workspace. The first section focuses on forecast performance and planning accuracy. Here planners can compare locked forecast, consensus forecast, and actual sales performance, along with metrics such as accuracy, bias, and forecast deviation. These measures help evaluate forecast quality and identify areas needing attention. Forecast values are available across planning periods, allowing planners to review projections month by month and understand demand movement over the forecast horizon. The table also combines inventory and demand flow metrics such as stock on hand, in-transit inventory, forecast per day, and days of stock coverage. This gives planners visibility into both expected demand and inventory readiness. Supply and replenishment indicators are also embedded directly within the planner view. Metrics such as reorder recommendations, safety stock, lead time, and ideal inventory coverage help support inventory planning decisions. Planning intelligence is further enriched through risk indicators and S&OP inputs, allowing planners to capture operational context and track planning risks alongside forecast data. Finally, segmentation fields such as ABC classification, cluster information, and contribution metrics help prioritize planning effort and identify high-impact items. The planner table also includes built-in column and date filtering, making it easy to narrow analysis to relevant planning windows or forecast types. Additional reports can be downloaded directly from the workspace for further analysis and collaboration. Planning data can also be downloaded and uploaded through CSV workflows, enabling teams to work flexibly across systems and planning processes. We will cover these enrichment and upload workflows in more detail later in this series. In this section, we will explore how planners can use filters, segmentation, and smart review workflows inside TrueGradient. Rather than reviewing thousands of items manually, planners can quickly narrow focus, identify important segments, and prioritize where attention is needed most. The filter panel allows planners to segment and navigate demand plans with flexibility. You can filter by product, category, location, channel, brand, cluster, or any available business dimension. This makes it easy to isolate specific planning contexts instead of reviewing the entire network at once. For example, planners may want to focus only on a certain category, brand, or regional segment to understand how demand behaves within that slice of the business. Once filters are applied, the forecast graph and planning metrics automatically update to reflect the selected segment. Reviewing every SKU manually is rarely practical. Smart Picks helps planners prioritize where attention is most valuable. Instead of scanning thousands of items, planners can generate focused review lists using configurable ranking logic. Smart Picks can be configured across different business dimensions such as SKU, category, site, or cluster. Planners can define how prioritization should work and select the criteria that matter most for the review. Ranking can be based on multiple signals such as forecast volume, consensus deviation, forecast change, accuracy, or other business indicators. This allows the prioritization logic to align with the planning objective. Once configured, TrueGradient generates a curated review list automatically. The system highlights the items most relevant for planner attention instead of requiring a manual search process. This helps reduce review effort while improving focus on material planning decisions. Planners can then move through the prioritized list and review items sequentially. Each selection updates the associated forecast graph and planning context, allowing rapid investigation of important cases. Beyond prioritization, Smart Review also helps surface potential forecast risks and unusual patterns. As planners move through prioritized items, they can quickly identify anomalies, volatility, unusual forecast shifts, or unexpected behavior within the time series. The visual forecast graph makes it easier to understand whether changes are temporary noise, emerging trends, or situations requiring intervention. This creates a faster and more informed review process. Traditional planning often involves reviewing large volumes of items with limited prioritization. TrueGradient follows a planner-first approach. Instead of asking planners to review everything, the platform helps direct attention toward the items most likely to influence outcomes. Prioritization lists, smart picks, and guided review workflows help planners spend time where it matters most. The result is a faster, more scalable, and more decision-focused planning process. Forecast enrichment is a critical part of the planning workflow, where planners apply business context and decision-making to improve forecast outcomes. In TrueGradient, enrichment can be performed through multiple flexible workflows depending on planning style and business requirements. In this section, we will explore the most commonly used approaches by planners to enrich forecasts. One of the most familiar ways to enrich forecasts is through direct planner table editing. Here, planners can review forecast values directly within the planning grid alongside supporting business metrics and planning signals. Forecast values can be directly selected and edited at the SKU and time period level, allowing planners to make precise adjustments based on market knowledge, promotions, operational inputs, or expected demand changes. This workflow supports granular control, where each value can be individually reviewed and modified without leaving the planning table. Changes are immediately reflected within the active planning workspace. Planners can also review associated context and business signals while editing, helping ensure that forecast adjustments remain aligned with broader planning assumptions and operational realities. Direct planner editing provides a flexible and familiar spreadsheet-style experience, making it easy to perform detailed forecast refinement across products, locations, and planning periods. Another powerful method of forecast enrichment is direct quantity uplift or downlift using the enrichment panel. This workflow enables planners to apply controlled forecast adjustments through a structured and traceable process. Within the enrichment panel, planners can configure the adjustment by selecting the enrichment type, defining effective dates, and specifying the business scope where the change should apply. Adjustments can be applied using any of the enrichment methods, enabling planners to increase or decrease forecast quantities based on expected business events or planning decisions. Planners can also document the business rationale behind the adjustment by adding enrichment details and comments, helping preserve planning intent and improving decision traceability across teams. Once applied, the enrichment is immediately reflected within the forecast graph, allowing planners to visually validate the impact of the uplift or downlift and compare enriched values against the original forecast. Another powerful method of forecast enrichment is through Excel export and re-upload. Within the enrichment process, planners can export the current working forecast into an Excel sheet for offline review and editing. This workflow is especially useful when planners want to perform bulk changes, collaborate with teams, or work through larger datasets using familiar spreadsheet tools. To begin, simply export the current forecast data. The downloaded file contains the forecast along with all the required identifiers and planning fields needed for enrichment. This ensures that any updates made externally can later be accurately mapped back into the planning environment. Once the file is downloaded, planners can open it directly in Excel and begin making adjustments. Here, forecast values can be reviewed and modified at scale. This may include increasing or decreasing quantities, updating selected periods, or applying planner-driven business adjustments across multiple SKUs simultaneously. Because the data is now available in spreadsheet format, planners can leverage Excel's native capabilities such as copy-paste, formulas, filtering, and bulk editing. This makes the process highly flexible and particularly useful when dealing with large volumes of changes. Teams may also use this exported file as part of their internal collaboration workflows before finalizing updates. After completing the required modifications, simply save the updated file. The changes are now ready to be brought back into TrueGradient. To re-import the changes, select Upload and choose the updated Excel file. TrueGradient automatically validates the uploaded data structure and checks whether the file matches the required planning format. Once uploaded, the system scans the file and identifies any modified forecast values. Rather than directly applying changes, TrueGradient first performs a controlled comparison between the uploaded file and the current forecast. This approval layer ensures full visibility and prevents accidental updates from being applied. After reviewing the detected edits, planners can approve the selected changes. Once approved, the uploaded modifications are applied directly into the enriched forecast. This export, modify, re-upload workflow provides a familiar and scalable way to enrich forecasts using Excel, while still maintaining the control, validation, and traceability of the TrueGradient planning platform. Along with traditional table-based enrichment, TrueGradient also enables direct graph-based enrichment, allowing planners to adjust forecasts visually and intuitively. To begin, Switch on editing mode and select the section of the forecast you want to enrich. You can define a range by selecting the start point and then extending or resizing it across multiple periods. Once the desired range is selected, simply apply the uplift or adjustment. These graph changes are immediately reflected on the forecast, allowing planners to review the impact visually before finalizing decisions. For faster workflows, graph enrichment supports multiple editing shortcuts and interaction modes. Depending on the use case, planners can adjust individual nodes, modify a selected range, or apply different enrichment behaviors directly from the graph controls. As changes are made, TrueGradient maintains a clear distinction between the original forecast and the enriched version, making it easy to compare before and after scenarios. Every graph enrichment action is automatically recorded within the enrichment history and enriched plan details. This creates a fully traceable planning workflow, where teams can review what changed, where the enrichment was applied, and how decisions evolved over time. With graph-based enrichment, planners move from manual spreadsheet-style editing to a faster, more visual, and fully auditable planning process.